Hi, my name is Tom Heffel, and this channel is all about helping students learn chemistry. In this video, we're going to talk about the compound copper chloride and how we can decompose it. So what I have here is a chemical reaction where copper chloride is actually being decomposed into copper and chlorine. Now remember, copper is going to be a solid and chlorine is going to be a gas, okay? And this copper is the +2 version, so sometimes we call that copper 2 chloride or cupric chloride. And as you can see, the copper is going from +2 to 0, and the chlorine is going from -1 to 0. So we have an oxidation reduction reaction, okay? Now, the chlorine is actually what's being oxidized, okay? Like I said, it's going up in oxidation state and it's losing electrons. And the copper is going down in oxidation state by receiving those 2 electrons and going from +2 to 0. Now, when we calculate the cell potential, we find out that when we take the cathode minus the anode, that we get a cell potential of -1.02 volts. Now, this negative sign in front of E cell tells us that this chemical reaction doesn't like to go in this direction. Remember, E cell would have to be positive in order for that reaction to take place. But since it's negative, this chemical reaction does not like to take place on its own, naturally, okay? However, we can do some electrolysis and we can actually push the electrons to make this reaction take place. So once again, because the E cell is negative, the reaction does not like to go in this direction on its own. So what we're going to have to do is we're going to have to use a power source to push the electrons in that direction to force the chemical reaction to take place. So what I'm going to do is I've poured some copper chloride, some cupric chloride into this U-tube, okay? And I'm going to place graphite rods in each end, okay? And then I'm going to place it into the beaker so it holds it as I connect my electrodes, my alligator clips, okay, so that I can push electrons in a direction that this normally doesn't go. Because you can see right now, the cupric chloride isn't turning into copper and chlorine gas all on its own, okay? However, if I use this power source, which is plugged into the outlet, I can push the electrons to force this chemical reaction to take place. And what I should see is I should see some solid copper start to form at the cathode, and I should see some chlorine gas start to form at the anode. So let's turn this on, and it might take a few minutes, okay, to get going. But I'm going to try to lift this up, and hopefully the alligator clips don't come off. They tend to pop off, so if they do, I'm going to have to put them back on. But I want you to kind of look at the very, very bottom here, and I can see a couple things taking place, okay? Number one, I can see some copper metal start to form here at the bottom, okay? And on the other side, I should start to see some gas bubbles. And I don't know if you can see those gas bubbles start to form, but you can see it's getting bubbly here at the top from these gas bubbles at the bottom, okay? And I don't want to let this go very long because the gas that I'm producing here is chlorine gas, okay? And chlorine gas is toxic, but I do want to let this go for a little while so that you guys can see that down here, you can see that copper really start to form here at the bottom. Here, let me press it towards the glass, okay? So that you can see that we're forcing this chemical reaction to take place, okay? So I'm just gonna set it back here into the beaker, okay? And I'm gonna turn this off just for a second, okay? And I'm gonna show you that production of the copper. So I'm gonna pull it out, okay? And you can see that copper. So this one, okay, where the production of the copper was taking place, this guy must be the cathode, okay? And then where the gas, the chlorine gas was taking place, chlorine gas, this must be the anode, and this must be the cathode, okay? So the electrons are leaving the anode and going into the cathode. And my question would be, well, what happens if I would simply just force the electrons in the other direction, okay? And making this one hooked up to the red one, okay? And this one hooked up to the black one, and let it go for a little bit. Now this might take a while, but the copper was over here on the left-hand side, okay? And if I let this go for a while, hopefully we see that copper go away, okay? And hopefully we start to see some bubbles on the left-hand side, because the left-hand side is now hooked up to the red side. And then hopefully we see some copper production over here on the right-hand side, because that's where the copper was being produced. But I do want to let this go for, I don't know, maybe like 30 seconds here to see if we can see bubbles on this side, on the left-hand side, okay, and the production of copper on the other side, okay? So basically the reverse of what we saw before. So let me pull this out. Hopefully the alligator clips stay attached, okay? And as you can see, I can see this copper. Let me try to turn it here. You can see that copper being formed on the right-hand side. And I don't know if you can see these bubbles taking place or not. It's kind of faint. You can kind of see those bubbles. Let's see if I can get a little bit closer. Start to form, okay? And you can see it's starting to get a little frothy here at the very top from these bubbles kind of coming up and hitting the front part here, and we can see the copper. So let me turn this off. And when I pull this out, we shouldn't see any copper there anymore. I don't see any copper, and I'm twisting it. Let's see, I'm trying to get a good camera angle, trying to see you twist it. And I should now have copper on this end, which is pretty easy to see. And as I twist it, they pop off, okay? But basically I just switched where the anode and the cathode was, but without this power source, this does not turn into copper and chlorine gas on its own. But when I hook it up to a power source that has a potential that's greater than 1.02 volts, I have it hooked up to 8. I don't know if you can see it there. I have it up to 8 to make sure it takes place faster. But if I hook it up to a power source, I can force this chemical reaction to take place and form copper metal and the chlorine gas. If you found this content helpful, please give it a like and subscribe. And when you add that comment, it really does push this information out to other students that might be interested in learning chemistry.